Okay, so we want to do a little bit now about what happens if some of these inside transformations are combined. So I want to think about this problem. G of x is equal to the square root of 3x plus 6. Okay? And so there are a lot of ways, I mean, this method that we were using before, where we were thinking of g of x as some square root of h of x, is effective here as well. So we want to kind of figure out what input values go to h of x. But I don't always, and I want to say this out loud, I really want to eventually get to the point where I'm not making a million of these, right, t-tables. It's very tedious. And the reality is you want to go to a point where you can just, like, you know what the base graph looks like. You can think about these transformations. And honestly, in a lot of places, without putting the base graph down, you just put down the transformed graph, right? So it's a very easy way to kind of generate graphs. So I can think about, in this case, how h of x solves to get 0. So 3x plus 6 is equal to 0. And if we solve this the traditional way, you would think about doing this shift first, and then you get to -2. Okay? And that's the right point. I mean, that is the right point. It's just that I don't want to have to solve this equation 4 times in order to get all of these points. Because if you solve this for 1, 3x plus 6 equals 1, this is, I think, -5/3, right? I mean, it's not kind of pretty, and I don't want to have to kind of do these even simple linear equations. Solving several of them is time consuming. So it'd be better if I could just see what the transformations were from this inside piece. And it happens that you can do that. One of the things that is helpful is if we compress first before shifting and then shift. But in order to figure out what that is and how that works, I have to in some ways factor this compression out and think about not solving this equation like I normally would, but think about doing something like this. And here, because this point 0, 0, we routinely, or like this point, at least that takes place at x equal to 0, shows very effectively what the overall shift in the graph is. Here is where I see kind of this shift, and you see it here when you factor out this 3. So really, if I think of this equation in this form, I see this horizontal shift, and then this horizontal compression, right? Which really, when I solve in this form, I do the compression first, shrink everything down, and then I shift it. Okay. So, and this is really the way that we want to do. So, one of the things that I have to do is kind of factor out this term in front of this x piece if it's inside. Okay? Okay. So this would have, like this graph, if I was going to graph this, this would be a horizontal compression. I'll just describe in words. Horizontal compression by a factor of 3. And then a horizontal shift left by 2. And then that will give me the graph of this function without having to kind of repetitively solve a whole bunch of linear factors. Okay? Okay. So it turns out, so then when I combine all of these kind of transformations together, there is an order that matters. in general, so one, factor out the multiplier, any multiplier inside, like we just did. Okay, and figure out what the actual compression is and what the actual shift is. 2, do a horizontal stretch or reflection, or both. You can do those in either order. Then horizontal shift, vertical stretch, reflection or shrink also, and 5, vertical shift. The most important, I mean, I know this looks like a long list. Really, you're doing compressions before you do any shifting. So if you compress these graphs, then shift, you're good to go. Okay? So will you guys try, I just want you to try, and we'll talk about this example, but try to graph f of x is equal to negative 2x minus 4 cubed plus 2. What's a 2? Try to do this. List out in words. List the transformations in words. First, I need you guys to, 1, identify the base graph. From your library of functions. Where are your base points coming from? 2, identify the transformations. And the order that you need to do them in, and then 3, try and graph. So bring that to class with you, and we will talk about it together.